All right, guys, I want to talk to you about something called a resultant. Resultant force. Okay? So, in physics and engineering, a resultant force is the single force obtained by combining a system of forces and torques acting on a rigid body. The defining feature of a resultant force is that it has the same effect on the rigid body as the original system of forces. So basically, we can replace multiple forces that are acting on something with one equivalent force to help us better understand what's actually happening in our system. So to go over this, I just kind of want to look at a quick example. So we're going to just draw a quick coordinate system here. Let's do this like that. So let's say we have a vector here. We'll call this guy vector C. Okay, and then C has a theta equal to 60 degrees, and C has a magnitude of 300 pounds. Okay, then we'll look at another vector. Call this vector D. Call this guy D. D is equal to 400 pounds and has a theta equal to 30 degrees. Okay. So what we need to do to solve this is the first thing that we need to do is break our individual vectors down into their x and y components. Okay, so if we're taking a look at vector C, we could draw vector C like that. Let's do this. Just draw vector C like this. So this is C, and then we will draw its x component. So this is its force C x component like that, and then its y component is force C y component, and then its theta was here, and it's equal to 60 degrees. Okay, so if we know that theta is 60 degrees, we can use our trigonometric functions to solve for FCY and FCX. So our FCX in this case is our adjacent, so we're going to use cosine. So we know that cosine, cosine theta is equal to our adjacent side over our hypotenuse. Okay, so if our adjacent side is FCX, our hypotenuse is just going to be C. So if we multiply C on both sides, we're going to get FCX is equal to C times the cosine of theta. So if we're doing some math here, we know that FCX is going to be equal to 300 times the cosine of 60, which is equal to 150, and then remember that's in pounds. So the same thing for our y component. We know that our y component here is opposite the angle. So we're going to use sine. So sine of theta is equal to opposite over hypotenuse, which is equal to FCY over c. So f c y is going to be equal to c times the sine theta. C is equal to 300. Theta is equal to 60 in this case. So FCY is going to be equal to 259.81. Okay, so we've broken both of those guys down. So now we need to look at our other triangle here, which was D. So D went down like this. So this is vector D. When we're looking at this, we'll have our x and y components. So our x component is to the right, so it will remain positive. But in this case, our y vector goes down, which makes it negative. Okay, so this is f dx and f dy. Okay, so just like before when we're solving, we've got also 30 degrees here. Okay, so just like before, we've got an angle. Its adjacent is f dx, and its opposite is f dy. So if we're solving for f dx, f dx is going to be equal to d times cosine of our theta, which is 30 degrees here. So if we plug that guy in, d is 400. If you remember from the example above, d is equal to 400. So it's 400 times the cosine of 30. So f dx is going to be equal to 346.41. And then if we do f dy here, it's going to be equal to d times the sine of theta, so that's equal to 400 times the sine of 30, which makes f dy equal to, remember f dy is going down, so in this case it's going to be negative, and that's 200 pounds, and this guy was pounds as well. Okay, so we've got all of our stuff. We've got both of our two vectors kind of broken down into their components. So all we have to do now is sum them together, and we should be able to get our direction, our sense, and our magnitude. Okay, so go back down here. So we had some force components in the x direction. So what we need to do is sum our forces in the x direction. The sum of the forces in the x direction, we've got two of them. We've got F, Cx, and we've got F, dx, okay? And those guys are 150 pounds and 346.41 pounds, okay? So the sum of the forces in the x direction is going to be equal to 496.41 pounds, okay? And then we need to sum the forces in the y direction. It's going to be equal to FCY plus FDY, which is equal to 259.81. That's pounds. Then remember FDY went down, so it's going to be negative. So this one's going to be a minus 200. So the sum of the forces in the y direction is going to be equal to 59.81. so what we're going to do is we can take those guys now and we can draw their force vector equivalent. So the first one was Fx. Okay, Fx was equal to 496.41, and then we had Fy, which is equal to 59.81, which gives us Fr, so the force resultant. So to solve for Fr, we need to use something that we've used before, which you know about. It's the Pythagorean theorem. So we're going to use a squared plus b squared is equal to c squared. Okay, so our a in this case, our a and b are Fx and Fy, and c is our resultant force. So we're going to take 59.81 squared plus 496.41 squared, and that's going to be equal to Fr squared. So if we square root both sides, we're going to get Fr equal to the square root of 59.81 squared plus 496.41 squared. We're going to get an Fr that is equal to 500 pounds. All right, so we found the sense. We know that the sense for Fr is up and to the right. That's the magnitude now is 500. So all we need left to find is our theta. Okay, so theta is right here. Theta, that's in degrees. Okay, so we need to find that. And the way we can do that is we can use any of our trig functions. In this case, I'm going to use tangent. So tangent of theta is equal to our opposite side over our adjacent side. Okay, so in this case, it's going to be equal to, opposite is 59.81 over 496.41. It's our adjacent side, which is, so that's tangent theta is equal to those. And to get theta by itself so that we can solve for it, we need to use something called the inverse tangent. So if you look at your calculator, you'll notice that right above the tangent button, there's an option for inverse tangent. So if we do the inverse tangent, looks like that. We're going to put 59.819 divided by 496.41, and that's going to be equal to theta. So theta in this case is going to be equal to 6.87 degrees. Okay, so that here is our direction. We've got our magnitude, and then our sense is right and up. Okay, so that was just a quick example of how you can solve for a resultant force when you're given any number of sources or of vectors. This process works out the same. You would just have to, with more than two, you would just have to sum up more than two force vectors.